Hello. Today we're going to talk about how to do a shortcut on graphing lines. We've been able to get points in lines, and we've found out how once we have the points to get the slope. We're going to show you a cool little shortcut here. First thing we're going to do is take these lines right here, find 2 points in them, and then find the slope from those lines. So here we go. We're going to do this little cute XY plot thing here. Say, okay, what's the nicest, easiest one to do? 0. You like stick in 0 there, and you get y equals, that guy goes away, and then have 5. 0, 5. That's a nice point, nice easy point. I'm going to pick another nice easy one, something that I can stick in there that'll get rid of that 3. If I stick 3 there, I get y equals 2/3 times 3 plus 5. Look at that, 2/3 times 3 is 2. So I get 7. So 3, 7. Now we're going to find the slope. Remember, slope, we're going to take y2 minus y1 over x2 minus x1. And we get 7 minus 5 is 2. 3 minus 0 is 3. Good. So we just found the slope. So if we were to graph this, we would have, here we have 0, 5 is up here about right there. And then we have 3, 7 is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 would be about right there. Good, good, good. And we can see that between this point and this point is the slope. And if you look right here, you can actually see the 2 and the 3, that it went from the level 5 to the level 7. And then it went from 0 over to 3. So it went up 2 and then over 3 to that next point. Good deal. Let's do the next one here. Little XY plot here. So again, zeros, it's just too tempting to get that intercept. So here we have 5 halves. Gives you 5 halves times 0 minus 3. That 0 cancels it out, and you get negative 3. And then a nice good one, I'm going to stick a 2 in there, so we get y equals 5 halves times 2 minus 3. And that's gone. 5 minus 3 is 2. So we have the point 2, 2. Now to find the slope, we're going to go y minus y. Let's do negative 3 minus 2 over 0 minus 2. So we took y1 minus y2 this time. 0 minus 2, and that gives us a negative 5 over a negative 2. That simplifies down to 5 halves. Good deal. So if we graph this, we have 0, negative 3. It's about right there. And then the next point, a 2, 2. 1, 2, 1, 2. And there's the line. And you can see, again, that slope, 5 halves, is illustrated 1, 2, 3, 4, 5. 1, 2. So it's up 5 over 2. And there we have it. There's the line. Good. And one more. Here we're going to have the xy. Stick in a 0, and we get 1. That's so nice. Notice that these, well, and for the next point, let's stick in something like, I don't know, 22. That'll get rid of an 11. Y equals negative 7 elevenths times 22 plus 1. That's y equals, times that through, and we get a negative 14 plus 1. Y equals a negative 13. Good. Slope here. If we do the slope of this one, we take y minus y over x minus x. So that's going to be 14 over 22, and that will reduce down to, negative, sorry about that, negative right there. 7 over negative 11, so negative 7 elevenths. Good deal. And if we graph this, we have the point 0, 1 is about right there. And we're going to go over 22 and down at negative 13, about right there. And here we have this line going down like that. Great. Now, looking at where the slope is here, the slope went down for these 2 points. It went down 14 and then over 22. Or reducing it, it goes down. Oh, we could have had a point right in there if we would have gone down 7 and over 11. That 14 over 22 reduced down to 7, 11, but you get the same exact thing here. And you can see this point. I don't know. Let's find out what that point would be. If we went down 7 from y being 1, that would put us at a negative 6. And over 11, so from 0 goes over to 11, so that's 11, negative 6 is that point right there. 11, and you can try this. Stick in 11 in for that x, and you get y equals negative 7 elevenths times 11 plus 1, and we get negative 7 plus 1 is negative 6. Oh my word, look at that. Isn't that fascinating that the slope could help us get a point? Now comes the really cool part of this. This is all stuff we've done in the past, but you'll notice we went all the way down here. We found 2 points. Then we found the slope, and we ended up with this number. And some of you may have noticed this before. Look at that. There's the number right there. We went down through here. We found 2 points. Then we found the slope, and we ended up right there. Oh my goodness, look at that number. We went through and even picked up some weird numbers, and look at this. The slope is right there, which is fascinating. We could actually, instead of doing all of this, watch and see what we could do. I'm going to graph all of these exactly the same way, but, well, we're going to get exactly the same line, but we're going to do it a lot quicker now. Watch this. So we're going to write up here what that shortcut is. When y is by itself, the number in front of x is the slope. And then this guy right over here is the intercept. So we still have 1 point that's really easy. So let's do this line now. We're going to go and graph it. First of all, you can tell me right away the slope, y is by itself, there's the slope. Slope is 2/3. And we have a good point, 0. We'll knock out that, 5. So we get 0, 5 is right there. And then the slope is 2/3, and that tells us where the next point is. We can go up 2 and then over 3. Right there, there's the next point. And if you want to figure out what that point is, you can. You can add 2 here and add 3 there, and you get the next point. But you see how fast that went? So next one, the slope is going to be 5/2, and the intercept is going to be 0, negative 3. So we go 0, negative 3, and we go 1, 2, 3, 4, 5, 1, 2. Go up 5, over 2, whoosh, and we graph the line. The next one, slope is going to be negative 7 elevenths. That was nice. And the point 0, 1. And we don't have to go through the whole process to find the slope. We can just pull it right out of there. 0, 1 is right there. And go down 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there's the next point right there. And we have that line, down 7, over 11. Notice we could have had the same line if we would have gone up 7, positive 7, and backward 11. And this, when we have it with y is by itself, put a little variable over there to represent the intercept, this is called slope-intercept form of a line. Y equals mx plus b. It's so nice because the slope, when y is by itself, is right in front of x, and then b is right there.
Let's quickly review how we graph lines using these other 2 ways. We first learned about the pick and stick method. Basically, that said, hey, pick 2 values for x, and it doesn't matter which 2 you pick. You can pick 5,000 for your x value if you really want, or 70 or whatever. Usually you should pick kind of easy numbers. I'm going to go ahead and pick 1 and the number 4. Once you pick those 2 x values, you stick it in. Pick and stick. So we plug 1 in. I get negative 2 times 1 plus 3. Negative 2 times 1 is negative 2 plus 3. That comes out to be just 1. So I'm going to graph the point 1, 1. Remember, this represents a point, the point 1, 1. So 1, 1 is right there. Now I'm going to stick in another number. I picked 4. So when we pick in 4, I'm going to do stick in 4. Negative 2 times 4 is negative 8 plus 3 comes out to be negative 5. So the point negative 4, 4, negative 5 is what I need to pick. Graph 4 and negative 5 is right here. And so my line would look like that. The second way we discussed about graphing was using the x and y intercept method, in which you just find the x-intercept and the y-intercept and then graph them. So to find the x-intercept, you simply let y equal 0. And to find the x-intercept, you simply let x equal 0. So if we did the same line, y equals negative 2x plus 3, and first of all we let y equal 0, so we'd put 0 in here for y, and we need to solve for x, so I'd subtract 3, and then divide by negative 2, so I get x equals 3 halves, which is 1.5. So I'd graph that. This is the x-intercept, and it's at 1.5, comma 0. Whoop. And then to find the y-intercept, we let x equal 0. If I let x equal 0, I get y equals negative 2 times 0 plus 3. Negative 2 times 0 is just 0, so I get y equals 3. And again, we get the same line graphed. We just used a slightly different method using the y-intercept and the x-intercept. So this brings us to our last method that we're going to be talking about today, which is using the y equals mx plus b format of an equation. So again, we know that m represents slope and b represents y-intercept. We talked about that a lot in our last lesson in 3.4. So if we know the slope and the y-intercept, we can actually graph a line as well. So let's say I've got the line y equals negative 3x plus 5. So I know what the y-intercept is. The y-intercept is 0, 5, and the slope is negative 3. Remember, slope is always with the x. So to graph, you simply would first graph the y-intercept, and then second, use the slope to find another point. Use slope to find a point. Let's show you how this would work. I'm going to graph the point 0, 5. 0, 5 is right here. Now I know the slope is negative 3. So remember, slope means rise over run. And so we could write negative 3 as negative 3 over 1. That means we would rise negative 3. I'm going to go down 3 from the y-intercept. 1, 2, 3, and over 1. And that right there would be my point. And then once you have 2 points, so again, we use the slope to find the second point. Once you have 2 points, just connect the lines.
Before giving you some to practice on, we're going to hear from Elder Clark Gilbert, who used to be president of BYU Idaho, and his take on how slope and intercept can help in the direction of our lives.
To demonstrate this principle, I will draw on some basic math. Now, don't panic at hearing the word math in general conference. Our BYU Idaho math faculty assure me that even the beginner will grasp this central concept. It starts with the formula for a line. The intercept, for our purposes, is the beginning of our line. The intercept can have either a high or a low starting point. The slope of the line can then be positively or negatively inclined. We all have different intercepts in life. We start in different places with different life endowments. Some are born with high intercepts, full of opportunity. Others face beginning circumstances that are challenging and seem unfair. We then progress along a slope of personal progress. Our future will be determined far less by our starting point and much more by our slope. Jesus Christ sees divine potential no matter where we start. He saw it in the beggar, the sinner, the infirm. He saw it in the fisherman, the tax collector, and even the zealot. No matter where we start, Christ considers what we do with what we are given. While the world focuses on our intercept, God focuses on our slope. In the Lord's calculus, He will do everything He can to help us turn our slopes toward heaven.
Great principles to guide our lives by. Let's get back to practicing math.
Okay, let's do a problem with a fraction in it, just so you can see how this works, the same idea. Again, you're always going to want to find your slope and y-intercept. Here's the y-intercept. Y-intercept is 0, 4. Always graph that first. Okay, then I find the slope. Slope is 3/5. So I'm going to use the slope of 3/5 to find the next point. Again, slope is rise over run. So this tells me to rise 3 and run 5 from my y-intercept. So I'm going for my y-intercept. I'm rising 3. 1, 2, 3. And I'm going to run 5. 1, 2, 3, 4, 5. And I connect the lines. That's it. That's how we do those types of problems. Let's go ahead and give you 3 problems to try in your own video notebook. Okay, so here are 3 graphs we'd like you to do. Go ahead and try to graph the line y equals 2x minus 5. That's number 1. Number 2, y equals negative 3/4 x plus 1. And number 3, y equals x plus 4. Go ahead and pause your video, and when you're ready to check, push the play button again. Okay, here we go. We got y equals 2x minus 5. Again, first thing we want to do is identify the y-intercept. That's at negative 5. So I mark it on the y. The slope is 2. You could also call it 2 over 1. So I'm going to rise 2, 1, 2, over 1. You could do that again if you wanted to keep going. But you only need to do it with 2 points. And that's what your line should have looked like. Let's work on number 2 here. Y-intercept is at 1. The slope is negative 3/4. Remember, slope is rise over run. So I rise negative 3. So that means go down 3. 1, 2, 3, and run 4. 1, 2, 3, 4. When you run, you always run to the right. I've seen a couple students sometimes try to run to the left. You should always run to the right. Y equals x plus 4. X plus 4, that's got a y-intercept of 4. So I mark that. And the slope's a little tricky here. There's no number in front of that x, so it's an implied 1. So we would rise 1 over 1, and that would be the line. Okay, how'd you do? Hopefully you did well. The last type of problem we need to talk about are ones that aren't written in y equals mx plus b form. So, for example, 5x plus 3y equals 9. This problem is not written in y equals mx plus b form. So if we want to use that method, we would have to solve for y first. So that's what I'm going to do. I'm going to go ahead and subtract 5x minus 5x to both sides. So I get 3y equals negative 5x plus 9. I then divide by 3. I get y equals negative 5/3 x plus 9 divided by 3 is 3. So now we have it in y equals mx plus b form. And because it's in y equals mx plus b form, we can go ahead and graph the y-intercept, which is a y-intercept of 3. And the slope is negative 5/3 rise over run equals negative 5 over 3. So this means to drop 5, run 3. So drop 5, 1, 2, 3, 4, 5. You do count the axis. Sometimes people forget to count the axis. I go down 1, 2, 3, 4, 5, and run 3. This would be where my next point is. Whoa, I kind of missed. I still kind of missed. Okay, but you guys get the idea. Okay, so if a line is not in y equals mx plus b form, make sure to solve it for y, and then graph it. Let's have you guys try 3 more. Okay, so here are 3 more problems we'd like you to try to do. You're going to have to get them into y equals mx plus b form first, and then graph them. So, the first problem is 6x minus 2y equals 10. Second problem is negative x plus 3y equals 12. And on this third problem, what we'd like you to do is I've given you a graph of a line. We'd like you to take that graph and use what you know about y-intercept and slope to write the equation in y equals mx plus b form. Okay, go ahead and pause the video, give these a shot, and let's see how you do. Okay, let's go ahead and solve this for y. I'm going to go ahead and minus the 6 over. I get 2y equals negative 6y plus 10. I then have to divide by 2, so I get y equals negative, oh, I'm sorry, this is negative 2y. So I divide by negative 2, I get positive 6, positive 3y minus 5. Oh, that's a little tricky. Make sure to get all your negatives right there. When you do that, I'm going to graph the y-intercept at negative 5. The slope is 3, so I go up 3, 1, 2, 3, and over 1. And this is the equation of that line. On this one here, we're going to solve for y. I get 3y equals x plus 12. I then divide by 3. I get y equals 1/3 x plus 4. So that's got a y-intercept of 4 and a slope of 1/3. So I go up 1 over 3 because the slope is 1/3. And we graph the line. Okay, great. So the last part here was that we needed to write the equation. Now again, when you write an equation, we're going to write out the y equals mx plus b. I'm going to let the b equal the y-intercept, which appears here to be at 1, 2, 3. So I'm going to put a plus 3. The slope, I go from one point to another point is the slope. So I rise 1, 2, and I run 1. So that would be 2 over 1x. You don't have to write it as 2 over 1 because 2 divided by 1 is just 2. Y equals 2x plus 3.
We're going to teach you about standard form of an equation of line. Now, before we really get into this, we've got to go back and look at slope-intercept form. We always had y equal to something. We had this great shortcut where the slope was the number right in front of the x, and the y-intercept was always this number right here, because when you stick in 0, m is gone, and y equals b. It was nice. So you run into problems that look like this, and you're like, ooh, y is not by itself. We can't even use this shortcut. You can solve for y. If you solve for y, you are able to do this, and we subtract 3x, and we get 5y equals, you can write 9 minus 3x, or we'll write minus 3x plus 9, because look at this. If the x's are written first, we'll be able to get the slope right there. Divide by 5, divide by 5, divide by 5, and we get y equals negative 3/5 x plus 9/5. We have the slope right there. Slope is negative 3/5. And then we also have the intercept right there, 0, 9/5. And we can graph the line just like that. 0, 9/5, that's almost 2. And then a slope of down 3, 1, 2, 3, 1, 2, 3, 4, 5. And there's our line right there. Let's see how this next one works. We subtract 2x from both sides, subtract 2x, and we get 9y equals negative 2x plus 10. Great. Divide by 9, divide by 9, divide by 9, and we have y equals a negative 2/9 x plus 10/9. We can graph this. Oh, let's write the slope down. Slope is a negative 2/9, and the y-intercept is 0, 10/9. Good deal. And the graph looks like this. We have 0, 10/9. That's just above 1. And the slope, we're going to go down 2, 1, 2, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. And we get the line looking just like that. Good, good. Now I want you to look at something here. All of these lines, well, here are the same two. I want you to look and see what is going on. See if we can do any shortcuts without having to do this every time. Now you are welcome to do this every time, and y equals mx plus b is the standard for a lot of people. Standard form is another way of doing it. It has some very nice shortcuts. So see if you can see this. The slope was negative 3/5. Instead of just looking up to this line, look all the way up here, and do you see something going on? See this guy right here? Do you see that? In that one and that one? Yeah, indeed. Is the same pattern going on here and here? Now you'll notice that this negative pops up. That's important to notice. That when we subtracted that 3x over, we put a negative on, and then we divided by that 5, and that's where that negative 3/5 came from. So if you're able to see the shortcut, the slope of this is going to be the opposite of this number because it got subtracted over. divided by that number. And that's where you get the slope. It's cool. Here's the slope of this one, the opposite of that one, over this one. Oh, isn't that nice? Now, what's interesting, we could, if we wanted to, we could get the exact same intercept if we stick in x as 0. Notice on this one, x is 0. This guy is now gone. 3 times 0 is 0, and we have this equation. 5 times y equals 9. Divide both sides by 5, and we get 9/5. Do the same thing over here, 0. If this is gone right here, divide both sides by 9, and we get 10/9. You'll notice same exact thing. However, there is one slight advantage to slope-intercept form. If we were to instead, we got fractions here, which were okay in graphing, but not as nice as some people might want. What if we stuck in the x-intercept, stuck in y as 0? Go like that, and we get 3x equals 9. Can you see the x-intercept there? 3 times what equals 9? It is indeed 3, right there. And on this one, if we were to stick in 0 for y to get the x-intercept, that guy's gone, and can you see that? X equals 5. So you can graph 0 9/5, just like we did over on this other one. Or you could graph 3 0, which is about right here, and then go down 3, 1 2 3, 1 2 3 4 5, 3/5, and there's our line. Now, I don't know if you can tell, but this line and this line are exactly the same thing. We just started on that point right there instead of the point up here, the x-intercept, y-intercept. See the next one. If we were to graph, instead of 0 10/9, if we graph 5 0 and then had -2/9, I'm going to run off the screen. I think I'll go up 2 and then backwards 9. 4 5 6 7 8 9. Good. Oops. And there we have it. Same line as what we had before. This right out here is 0 5. Let's try a couple more. Okay, so here are a couple more examples. Let's recap on what the shortcut is. If you have a formula that looks like ax plus by equals c, where a, b, and c are numbers, then when you solve this for y to get it in a slope-intercept form, the slope, the number in front of x, will end up being the opposite of this number, a over b. There's our shortcut right there. So in this case, we can do the slope is the opposite of 3 over 7. And it works just like that, the opposite of 3 over 7. Can you find a good point? You can either do the x or the y-intercept, and it takes a little bit of work, but if you do the y-intercept here, that guy goes away, and we have 3x equals 9, which is x equals 3. So we have 3 0, and down 3, 1 2 3, 1 2 3 4 5 6 7, and voila, there's our line. Let's try this one. The slope is the opposite of 4 over, now remember this is a -1, so that's -1. Do you see how that negative and that negative cancel, and we get slope equals 4. There we have it. So the slope is 4, or 4 over 1. Oh, we need a good point. I kind of like the x-intercept a little bit better. We could do the y-intercept. I like the y-intercept where x is 0. So if we stick in 0 there, you can see this guy goes away, and we just get -y equals 11, so y equals -11. So 0, -11 is our intercept. 0, -11, and then slope 1 2 3 4 1. And there's the line. Can you see how nice this is to go ahead and be able to use the standard form to try it? Here are a couple problems that you should try in your video notebook.
To the boards!
Try these 3 problems, and when you go ahead and press pause, and when you're ready to proceed, keep going with the video. Okay, welcome back. How did you do? Hopefully you did all right on them. Let's give it a try. This one, the slope is going to be a -2/7 following that shortcut. And if we can look, does 2 or 7 go in? It looks like if we knock out that one, we'll have an easier equation. So if y is 0, x is 2, we have the x-intercept. So we have 2, 0, and -2/7 slope. 1, 2, 1, 2, 3, 4, 5, 6, 7. And there's our line. Over here on this one, the slope is going to be the opposite of 8 over -3. That's a positive 8/3 slope. And we got to get at least 1 point still. 8 into 12 doesn't look so good. I'd like to get rid of the 8, so I'm going to put a 0 in for the x, and I get a nice easy equation here where y has to be a -4. There's 0, -4 right there, and a positive 8/3 slope. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. And there's the line. Good. And the last one here. Slope is going to be a negative this number over that number. So that's a positive 4/5 slope. And, oh, neither one of those looks like it goes into it very well. So it doesn't really matter. Let's let y equal 0, and we get x is 1/4. The x-intercept right there. So 1/4, 0, and then slope 1, 2, 3, 4, 1, 2, 3, 4, 5. And there we have the other equation. To summarize, standard form. If it's written like this, you are welcome to use a shortcut, or if you prefer, you can go ahead and solve for y. And you'll notice if you do that, you'll get y equals, and you subtract that ax over there, and then you divide by b. Divide by b. So you'll get that as your slope. You're welcome to get y by itself, and then just use the y-intercept all the time. There's just one thing more we've got to talk about. So we're going to do another equation, something like this, x equals 7. You guys have seen this one done before. It's out where x is always 7. Goes up and down like this. And it's straight up and down, has a little intercept right there. I wanted to draw that up here so we could look at all of these different equations and kind of collect what we've done. Notice if we get this slope, we know, and this connects up with this, that this is slanted down when we walk to the right. Other thing that happens, you can see if we extend this all the way, not just to the 2 points, but all the way along, that we are in quadrant 1, quadrant 2, and quadrant 4. This guy, however, is absolutely vertical, and it's in quadrant 1 and quadrant 2. Even if you keep extending forever, because it's just straight up and down, it'll never go over into these other quadrants. It has an x-intercept that's positive, and no y-intercept whatsoever. This guy has a positive x-intercept, it's over here on the positive side, and a positive y-intercept. We look at this one, this is slanted upward to the right, so up as we go to the right, and this is because it has a positive slope. Positive means you're going up, as opposed to this one had a negative going down to the right. So if we look at this one, it has a negative y-intercept, a positive x-intercept, and it goes in quadrant 1, not in quadrant 2 ever. There's quadrant 4 and quadrant 3. It's down there. Here are some others. This is going to be slanted down as we go to the right. It has a positive x-intercept, a positive y-intercept, and it hits quadrants 1, 2, and 4. Now it's possible that you could have one go right through the origin, kind of like that, and only get 2 quadrants, but every line, if you keep extending it, will hit 3 quadrants unless it goes right through the origin, is vertical, or is horizontal. So this one goes up to the right because you have a positive slope, and it is in quadrants 1, 4, and 3. And similar 1, 4, and 3, and goes up and to the right. Oh, x and y-intercepts is a positive x-intercept and a negative y-intercept. We can tell everything about a line by that.